Hey all, so today we are going to discuss some more problems in quantum mechanics based on vector space. So let us talk about this problem number 46 in this series, which says that consider a 3D vector space spanned by an orthonormal basis 1, 2 and 3 and gates alpha and beta are given by alpha equals to I1 minus 2 into state 2 minus I basis 3, and similarly beta is I1 plus 2, 3, right? The 2 is obviously some eigenvalue corresponding to the eigenstate, right? Now it is asked that find the inner product of alpha and beta. Remember that this is whatever is given in the kate, alpha and beta are kate. Whatever here it is asked that this is bra and this is kate. So what does it mean? That to calculate the inner product, this inner product, you first need to calculate the bra corresponding to this kate, right? Let us solve it. So solution, even though the problem is easy, but you need to be careful. So it is asked that kate, let us calculate the kate, bra corresponding to this kate, which is equals to alpha star, right? So what it is? It is equals to nothing but minus of I 1, right? And this will remain as such, as this is not a complex quantity, 2 and then plus I and 3. So this is your bra corresponding to kate alpha, right? And now beta is given, so inner product alpha beta is simply equals to nothing but this. You know that bra is nothing but the row and the kate is nothing but the column. So it's a simple matrix multiplication. I1 minus 2 plus I3, right? And then it's completely multiplied by this vector, which is I1 and then 0 multiplied by 2, where there is no eigenvalue associated with 2 and then 2, 3. Now just take the simple multiplication as there are orthonormal bases, as it is already says, so there will be no cross multiplied term. Remember that. So only term which will appear is that 1 multiplied by 1, 2 multiplied by 2 and 3 multiplied by 3, right? So what it will give you is nothing but minus I multiplied by I 1, then minus 2 multiplied by 0, 2, and then I multiplied by 3, 2, 3, 3. So what does it gives you? I is I square with minus, I square is already minus 1, and then minus it gives you plus 1. It is plus 1, and this gives you 0, and this gives you 2i. So this gives you 1 plus 2i, as this is 1. There are orthonormal states, remember that, 1. So 1 plus 2i is the answer. The inner product of alpha beta is nothing but 1 plus 2i. This is a simple question and simple answer. Right? It's similar problem appears anywhere in the exam or in some of the intermediate terms of some of the questions. You will be easily able to tackle it. Right? Now let us discuss this next problem, problem number 47, which says that considering an unnormalized state which is given in terms of 3 orthonormal vectors as follows. Psi in terms of phi 1, phi 2, phi 3 with normalization factors, right? Where phi n are eigenstates of an operator b cap, so that b cap phi n is n square times phi n, where n equals to 1, 2, 3. Then the expectation value of b cap for the state psi would be what? Right? Now let us calculate this problem. So before starting, you need to read the problem very carefully. And it says that in unnormalized state, right? So it means that the state is not normalized. So first let us normalize this state, right? To psi star psi, which is right. It will give you how much? So it is 1 upon root 2 multiplied by 1 upon root 2 into theta phi 1 phi 1, right? And then 1 by root 5 multiplied by 1 by root 5 phi 2 phi 2, then multiplied by plus 1 by root 10 multiplied by 1 by root 10 phi 3, right? So this is given here as phi 1, phi 2 and phi 3 are orthonormal state. This will give you immediately 1, the inner product. So you are left with this value, which is 1 by 2 plus 1 by 5 plus 1 by 10. So how much it is? If you take the LCM as 10, it will give you 5 here, 2 here and 1 here, which is 8. Right? 5 plus 2 plus 1 are 4 by 5. So its the normalization value is 4 by 5. It means that you have to multiply by root 4 by 5, but this is multiplication. So this root of this will be multiplied with all the field size, they will be normalized, right? Now rather than that, as we are calculating the expectation value of B, let us go to it. Now to find the expectation value of B, what we will do, we'll simply psi B cap psi, right? This is what we are going to do. Now B cap operating on psi gives you n square into phi n. So psi, it is how much it is? 1 by root 2 phi 1, right? And divide by obviously psi. This is what we call the expectation value of B, right? Psi B cap psi divided. So this will be giving 1 by root 2 phi 1 plus 1 by root 2 phi 2, 1 by root 5 phi 2 plus 1 by root 10 phi 3, right? Sorry, this is not, these are caps, bra, right? You need with the bra, as this is complex conjugate, or missing conjugate, right? Then B cap, along with the B cap operating on phi n. So B cap operating on phi n giving you n square times phi n. So operating on 1 will give you 1 square, 2 gives you 2 square, 3 gives you 3 square, right? So giving you 1 by root 2 phi 1 plus phi 2 square divided by root 5, and B operating on the state, giving you phi 2, right? And then 3 square divided by root 10, phi 3. Now just multiply both, remember that one is row and the rest is column, and obviously divided by this 4 by 5. So how much it gives you? Now you just multiply by the cross terms. So 1 by 2 gives you 1 by 2, phi 1 phi 1, plus 1 by 5 and 4 by 5 giving you 4 by, so root 5, 4 by 5, phi 2, right? Plus giving you another term which is 9 by 10 phi 3 phi 3. And whole divided by, this is 4 by 5, which gives you 5 by 4. Right? Now just try to simplify it. So this gives you 1 by 2 plus 4 by 5 plus 9 by 10. right? Take the LCM. This gives you 5 by 10, this gives you 8 by 10 and 9 by 10, right? Let's just calculate here. 5 by 4 multiplied by 5 by 10, 8 by 10 and 9 by 10. How much it is? So just count it. 9 and 8 is 17 plus 5 is 22 divided by 10 multiplied by, so this gives you 2, this 22 by 8 or 11 by 4. So expectation value of B is nothing but the 11 by 4, right? So this is how, this is a very significant problem. It is a little tricky, asking about the unnormalized state, which people usually don't care of, don't look into. Usually they forget about it. And then this thing, when you are operating on the state, you will be operating on the state side only. And after the operation of this state, this operator on the state side, you will take the inner product with that, the other state, right? So this is a very important problem. Will be helpful in solving many other problems later during the exams. Now let us discuss one more problem, which says that consider a pair of orthonormal kits V1 and V2. The dual of kits V, the dual of the kit V, which is equal to 5 minus 3i V1 plus 3 exponential of minus of I 3 pi by 2 V2 will be what? So let us calculate the dual. The dual is nothing but the Hermitian conjugate, right? So it is what? So dual will be V, which is equals to star, right? And what it is? It will be, just take the complex conjugate. So 3i will become positive, this becomes B1, and this remains same, and this becomes positive. I 3 pi by 2 with V2. Right? So this is a one-line answer, taking the complex. Remember that this was your kit, this is bra. Now this is a column element. So when you are taking matrix multiplication, you will write it as a column. Sorry, this is not a column. This is a bra. So this is a row. The kit is column. So this is row and this is column. When you will taking the multiplication, you will be taking row multiplied by column. Right? So it's a simple one-line answer. Now I discuss this problem, which says that consider an operator B cap phi1, phi2, the outer product. The phi1, phi2 are orthonormal, then find the value of B square and BB dagger. Right? So what is the solution? You have to calculate B square and BB dagger. So what is B square? B square is B and B, right? So just keep it like that. Remember that they are operators and they are multiplied in order. So this, then phi1 and then phi2. Right? phi1, phi2, phi1, phi2. And now but the product of phi1, phi2 is nothing but 0. Right? So it means as they are orthonormal, so it means that this is 0. Right? Now let us take to this BB dagger. BB dagger is what? B is phi1 and this is phi2. Now what is the dagger of B? This will give you phi2 and then this gives you phi1. Right? Phi2 goes here, phi1 goes here. So this inner product is giving you 1. So you are left with phi1 outer product, which is nothing but projection operator. Right? So this projection operator, B beat 5 and 5 1 or 5 2 5 2 or 5 and 5 and outer product. Right? So this is what we have got. Simple problem. Now let us take to another problem which says that what is the parity of position and momentum operator. Of position and momentum operators. Right? So just solve it. It simply says that a parity operator operating on any of the vector, position vector R will give you minus of R P cap. Right? So it means that it changes the parity of position operator. So X goes to minus X or like that. Similarly, P cap operating on momentum operator, right, gives you minus of the momentum operator P cap. So it means that the position and momentum operator both are parity operators. Right? So both position and momentum operators are parity operators. So now that's all for today. We will come up with more number of problems on the next new topics in the next lecture. So please go through these lectures and just try to understand these solutions. If you have any problem, do comment in the comment section. We will come to you if any problem arises like that. We'll try to address it. Please do like and subscribe. Also share with others who are interested in it. Right?